Hey guys, welcome to your next tutorial. In this tutorial, we are finally going to display a texture on the screen, and there's a few small things we need to do before then. But first, I want to show you a bug that I had in the previous tutorial. First of all, if you go to the decode PNG declaration, I forgot to put a semicolon. Now, y'all probably didn't forget to put a semicolon, but if you copy pasted my code, you may have forgotten to, and it would have given you a really weird error actually in another file. So that fixes that. Another thing we forgot to do is if we go to imageloader.cpp, this loads in the width and height. It grabs the width and height from the texture, but we never set the width and height of our let me move this down, of our GL texture, because remember GL texture also has a width and height field that we added just for our own benefit. So let's go ahead and do that before we return it. We're going to say texture.width equals width and texture.height equals height. There we go. And one last thing, this is not a static function. Let's actually make it a static function for now. We may want to unstaticify it later, but for now, static function will just make this much simpler. All right, so now what we need to do is load this image, or an image. Let's go ahead and pick which image we want to load. So here is our little Jimmy Jump pack that I talked about in the previous tutorials. You can use any textures you want. You don't have to use the exact texture I'm using. I'm going to use probably character right standing. I think that looks like a good texture. So let me put this over here. Let's go into our where are we? Let's go into our actual main game. So main game.cpp. So we have sprite.draw here. What we're going to want to do is bind a texture before we draw this sprite so that we can actually use the texture. But we don't have the texture in the game yet. So for now, what we're going to do is open up main game.h, and we're going to store a GL texture here, just like we stored the sprite. Now remember, we're not going to want to do this in our actual game. We're not going to want a bunch of sprites and textures here in the actual main game class. This is just for simplicity while I teach you these concepts, and we are going to make the code a lot better once we move on a little bit. So let's go ahead and include, and we're going to include GL texture, GL texture.h right there. So let's create a GL texture, GL texture, and let's just call it player texture. Now remember, this is temporary. So it starts out initialized to 0 because of its constructor. What we need to do is actually load the texture. So let's load the texture let's go ahead and do it in run. I think that's where we do the sprite. Yeah, that's where we initialize the sprite. So let's go ahead and load the texture here too. Again, this is temporary. So to do that, what we need to do is up here at the top of main game.cpp, we need to include our image loader.h. So player texture is going to get loaded by image loader : load png, and that will load it and return a GL texture. So we're going to say player texture equals that. And now we need to pass in the file path, and this is going to be the relative file path to our working directory, which in our case the working directory is oops, that's Seed of Andromeda. I always do that. Our working directory is the graphics tutorials folder that has all of the folders here, like the shaders and the textures folder. Basically, the folder that has your VCX project, this is your working directory. It should be. If it's not, let me know and I can help you fix that. So the relative path is going to be textures / Jimmy Jump Pack / PNG / character standing right or whatever. So let's go ahead and do that. And let me move this over here so I can copy the path really easily. All right, so textures / and then Jimmy Jump Pack. Make sure you spell this right or you won't be able to open it. You'll get an error. / PNG / character right standing .png. Hopefully I typed that in right. If not, we will know because it's going to give us an error. All right, so that should load the texture. And let's go ahead and run that and see if it does load the texture without giving us an error. We should get build errors. Of course we get build errors. We are getting redefinition. So this is a good error for us to get so that you know what to do about it. So I created this GL texture.h and I included it in, I guess, several places, and now I'm getting this error struct redefinition. The reason I'm getting a redefinition here is because I didn't type pragma once at the top. What pragma once does is it keeps you from having what's called like a circular include, or including the same thing multiple times. If you have two files that both include GL texture and perhaps these files also include each other, then you're going to get the definition for GL texture multiple times. Having a pragma once will fix that. There's also something called include guards. You can look that up, and it does the exact same thing as pragma once. It's pretty much whatever your preference, but this is the easier way to do it. All right, so that fixed that. Let's go ahead and run it. And we should get, there we go. We got the same thing we already had. We didn't get any error messages, which means it did successfully load that texture for us. Really cool. So let's go ahead and stop it, and let's use that texture. To use the texture, what we have to do is we have to pass it to OpenGL, or pass it to our shader as a uniform variable. Now remember, a uniform variable is a variable that is basically constant over your entire mesh, and textures are something that is going to be constant. So to do that, what we need to do is go to our fragment shader, and we're going to make a new uniform. And for textures, what you use is something called a sampler. So basically just any texture, a one-dimensional texture, two-dimensional texture, those are called samplers in GLSL. And we're going to say sampler2D, since this is a 2D texture, and we're just going to call it texture. But let's not call it that, because there's actually a function called texture. So let's call it player texture, even though this is, let's just call it sampler, my sampler. Really generic name, since this is just a very generic shader. All right, so you can call it something else if you don't like that. Now what we need to do is get the color from the texture. So let's make a vec3, this will be RGB, and let's go ahead and say equals, and to get the texture from the sampler, you make a call to texture, like this. And so the function we're going to use to actually get the color from the texture sampler is this texture function. And the first parameter it takes is the sampler that we want to get the color from. So we're going to say my sampler. And the second value that we have to put in here is the UV coordinates. Now, UV coordinates are what are known as texture coordinates. It's basically the coordinates of your texture for this particular pixel. So let's go ahead and take a look over here at Paint. I already drew us a little example. So here's our texture here. It's a little angry face, or I don't know, evil face. And we have here on the y-axis, it's called V, and on the x-axis, it's called U. You can basically think of U as X and V as Y. And the coordinates range from 0 to 1. So let's say we are making our little person, our little standing sprite or whatever. We want to load in this texture. And what we're going to do is, since we are displaying this texture on a quad, right, on our sprite, which is just 6 vertices, for 2 triangles. What we're going to do is the bottom left-hand corner is going to have 0U and 0V. The bottom right-hand corner is going to have 1U and 0V. You see how that works? The top right-hand corner is 1 and 1. And if we do that, it will display the texture correctly. However, if we were to do something like set the right side to 2 and the top and the left side to 2, so the U is 2 and the V is 2. If we were to do that, what's going to happen is, instead of just getting 1 copy of this guy, we're going to get 4, if I can do this, we're going to get 4 small copies of him, like this. We're going to get 4 of them, because it's going to map 0 to 1 to 1 texture. So if we have the coordinates 2 in the bottom right-hand corner of our quad, we're going to have 2 copies of the texture. If this was a 4, we would have 4 copies of the texture. If the bottom right hand was 0.5, then we would only get half the texture. See how that works? The UV coordinates are a way for us to map the texture onto our actual geometry. And once we're loading in more complicated models that have complicated textures, we're not going to really have to manually pick these texture coordinates. They're going to be in the actual data for the models that we load in. So that's enough of that. That should be pretty easy to understand. If I confused you with that, just let me know in the comments and I will clarify. So we need to pass in the actual UV texture coordinates. That's going to be another attribute for our sprite shader. So let's open up our graphics tutorials and go to the actual sprite. So here we have the vertex data, and here's the vertex. Let's go to the vertex struct. You can go to the definition with F12, or you can right-click, go to definition. So here we have a position, we have color. Let's make a new struct out here, struct UV, and we're going to do a float u, and a float v. Like that. So we're going to say UV, UV. So this is the UV texture coordinates. All right, so this is going to be a number between 0 and 1 if we want to do just the normal texture mapping. So let's go back to sprite.cpp. So now we have an additional little field that we need to set. Oh, and before we do that, what we should also do is add some little functions in here. We can add some helper functions. For instance, void set color to make setting the color easier. And we can say GL, did we do a GLU byte for the color? Yes, we did. We could say GLU byte R, GLU byte G, GLU byte B, GLU byte A. This will make setting colors easier. I forgot which YouTube commenter told me this, but I will put his name in the description. So what we can do is we can say color.r equals R, color.g equals G, color.b equals, oh my goodness, equals B, and color.a equals A. This is going to make things easier. Having functions inside your struct does not increase the size of the struct. This doesn't take up any RAM or anything like that. It's just going to take up very little space in the code memory. And we can use it to easily set the color instead of having to do it the hard way with, where are we? With this right here where we did vertex data 4.color.r, all that. Instead we can say vertex data 4.set color, and we can say 0, 255, 0, 255. Look at that, isn't that cool? So we're going to do the same thing with the UV coordinates. Let's but first let's do this. Let's do it properly. 0, 0, 255, 255. In a lot of these tutorials, we are going to probably go back and correct things and constantly make it better. That's the point of these tutorials, is to give you guys some actual production level code eventually that's going to be really reusable, and y'all should be able to learn a lot about how to actually structure your code and make things a lot easier. So look, we just cut out a bunch of lines of code using that little function, and it's not going to slow down our program or anything like that. It's going to be really great. All right, so there's setting the color. Now let's set the UVs. So let's make a UV setting function, and we can do the same thing with position. I always lose the header files. I should pin it. So I will pin sprite.cpp and I will pin sprite.h. So let's make, oh, that's not what I wanted to do. I wanted vertex.h. Whatever, that's fine too. Let's do a void set UV, and we're going to say float u, float v, and this will just say uv.u equals u, and uv.v equals v. And let's also do the same thing for position to make this consistent. Void set position, and we're going to say float x, float y, position.x equals x, position.y equals y. There we go. There's our three functions. Now we can make our sprite stuff a little bit cleaner. So let's go ahead and set the UV. We're going to say vertex date. Actually, we can set the UV by the position. That'll make it a lot easier. So first, let's change this to use the new function vertex data 0.set position, and it's going to be x.width and y plus width, x plus width. There we go. Now let's set the UV coordinate for this one. So if we remember, the first vertex is this top right one here. This is plus width plus height. So it's going to have a u of 1 and a v of 1. Okay, so let's say vertex data 0.set UV, and we're going to say 1.0f, 1.0f. Simple as that. Now let's do the same thing for vertex position 1. There we go. And this is x and y plus height. Careful of copy pasting, it is dangerous, but I am a pro at copy pasting. Actually, I'm not. I always make errors, but I never stop doing it. Vertex data 1.set UV. And so this is y plus height and x. So x is going to be 0. This is the top left-hand corner. And the y, or v, is going to be 1.0f. There we go. And we're going to do the same thing for vertex data 2, except it's just x and y. Oh, geez. X and y. And for the UV, we are going to just set it to 0, 0. 0, 0. Now, we're doing all these vertices by hand, right? And it's only 6 vertices, so it doesn't take that long. When we're doing more complicated models, we're not going to be doing it by hand. Instead, we're going to be loading model files, and it's going to all get set up automatically for us. All right, so vertex data 3.setPosition. This is xy again, 0, 0 again, because it's the same as vertex data 2. This is the bottom left-hand corner. Both of these vertices are. Now we are at the bottom right-hand corner. So I'm just going to copy both of these and change them to the correct values. This is 4, 4. And for the bottom right-hand corner, that's x plus width. And x is u is 1.0f. And finally, for the last one, it's the exact same as the first one. So copy that and change this to a 5. Or don't copy it if you want to be a good programmer. There we go. So that's going to set up our UV coordinates and our positions for all of our vertices. Now we are getting pretty close. Let's go ahead and modify our shader to be able to handle that. We're going to say in vec2 UV. And what we're going to do is just pass the vertex coordinates through to the fragment shader. So remember, they're going to get interpolated between the vertices so that each pixel knows exactly what coordinate it is. So it knows exactly where to get the color from the texture. So we're just going to say out vec2 fragment UV. Let's call this vertex UV to be consistent. So down here somewhere we can say fragment UV equals vertex UV, pass it right through to the fragment shader. And I'm going to copy this right here, move it over to the fragment shader, and change it to in vec2 fragment UV. And finally, of course, a semicolon. Did I forget one over here? Yes, I did. And finally, what we can do is grab fragment UV and put it right here. So that's going to say, look up the texture my sampler and look up the coordinates that are specified by fragment UV. And that's going to return us a 4-component vector, but this is a 3-component vector because it's going to return RGBA. So we should change this to a vec4 so we can get RGBA. All right, so now we have the texture color. So let's go ahead and comment out this part right here for now. We might come back and use that to make our little guy change colors. So let's say color equals, and we're going to say take just the, oh, I didn't even name this variable. What's wrong with me? We're going to call this texture color. Jeez. All right, so texture color is going to set the new color. But we also want to take into account the fragment color because we want to be able to take our little, take our little guy, where is he? PNG, our little character right standing. We want to be able to color him different colors. We don't want him to always just be the solid blue color. So what we can do is just multiply our fragment color by his texture. And that will just take the two colors and multiply them together. So if fragment color is white, it's not going to do anything because that's like multiplying by 1. If fragment color is completely black, that's going to make the texture completely black because it's like you're multiplying by 0. This is just this is one way to do color blending. There's lots of other ways to actually blend this. We could add them together, but then it's going to be really bright. We could subtract them. We could do all sorts of weird things. I'm just using multiplication because it typically looks pretty good. All right. So there we go. That is that. That sets it up, blah, blah, blah. We are getting close. A few more things we need to do. We need to make sure our shader knows that we have an additional vertex attribute. So we need to go to where we initialize, that is seed of Andromeda. We need to go to where we initialize the shader. So I believe that is in main game.cpp initialize systems. I believe, here we go, init shaders. Let's go there. Oh, here we are. So we need to add one more attribute here. We're going to add the attribute vertex UV, just like that. Yes, that will add the attribute. And I believe that's all we have to do there. Now we need to, finally, we need to bind the texture. Yes, we need to bind the texture, but it's not fine. It's not the last thing we have to do. We are getting close though. So this is going to use the program. Now let's bind the texture with GL bind texture. And we're going to bind GL texture 2D. And the texture we are going to bind is the ID of our is it called player texture? I believe we called it that. Yes, it's player texture. So player texture.id. That will bind the texture. Now once we're done, we don't have to, but it's always a good safe thing to do to unbind the texture. So we're going to say GL bind texture, GL texture 2D 0. That will unbind it. So before we bind the texture, what we want to do is make sure we're using the very first texture unit. There's something called multi-texturing where you can have multiple textures bound at one time. We're going to use the first one. So to do that, we're going to say GL active texture. And here the enum that we pass in is GL texture 0. That's the first texture. There we go. Now what we need to do is we need to tell in our fragment shader, we need to actually pass the uniform in. And what we do to do that is we just pass in an ID that's telling it which texture unit we're using. Because remember, I told you there is multi-texturing. I'm not going to tell you exactly what multi-texturing is, but essentially it means you can have multiple textures and multiple samplers in here if they each use a different, If they each use a different active texture. So actually it's not that hard to explain. We could do active texture 0 and bind this texture, and then we could do active texture 1 and bind another texture, so we could have two textures in our shader at once. You can do that with a lot of textures actually. So what we should do now is tell the sampler which texture unit it needs to use. So what we're going to do is say GL uniform 1i for integer, and the actual location for the uniform we're going to get with GLUint. It's actually GLInt here, GLInt, not GLUint. I clarified that in the previous tutorial, I believe. GLInt, and we're going to say texture location equals color program dot get uniform location. This is what tells us what our handle is so that we can actually set the uniform. And the uniform name is, what the heck did we name it? We named it mySampler. What a dumb name. So we named it mySampler. And we're going to say, all right, I want to bind to texture location. I want to bind the value 0. And that's telling it that we are using GL active texture 0. If we change this to a 1, then we could put a 1 here. So I hope you understand how multi-texturing works. We can do this with many different textures. But only one texture can occupy each texture unit. All right, so that will bind the texture, send the texture. We have the texture coordinates, all of that. Dare I say we are done? I believe we may be done. Let's run it and see. There's always some things I forget. I'm not confident this will work. There we go. So uniform time not found in shader. Did I get rid of? That's right. So here's a little something that y'all need to know. Whenever you have a variable in your shader that is not being used, for instance, here in the fragment shader, we have this uniform time variable. And normally we were using it here to make our crazy colors, but now we are no longer using it here because I commented out. Well, what OpenGL is going to do is it's going to just delete this basically whenever we compile. It's going to get rid of it because it doesn't need it. So when we come down here to get uniform location of time, it's going to give us an error because it's looking for the time variable and it doesn't exist. So to fix that, we can make sure that we're still using time here so it doesn't get optimized out, or we can just, comment this out for now. So let's comment it out for now, see if that solves our problem. And we get a null access violation, which means I did something wrong. I'm going to pause the video and figure out what I forgot. Well, it's actually pretty obvious what I forgot, at least one of the things I forgot. We need to set up the vertex attribute pointer. So this is the UV attribute pointer. So remember, just like the position and color, anytime we have a vertex attribute, we have to point OpenGL to the data in our vertex struct. This right here, this vertex. So I'm just going to go ahead and write to the next line, GL vertex attrib pointer. This is the second attribute, and it is 2 elements in size. It is a GL float. We do not want to normalize it. GL false. The size is, of course, size of vertex, or the stride. That's just the size of our vertex, excuse me. And finally, the offset is void star, and then offset of, in vertex, we want the offset of our UV variable. There we go. Now maybe this will work, maybe we'll still get an error. Let's try it now. Holy crap, it worked. Good job, guys. Look, we did it. So you immediately notice that our little guy is upside down. Now, the reason he's upside down is because OpenGL uses a weird texture coordinate system that basically flips the V coordinate. Now, there's several ways we can go about fixing this. We could read in the texture and then flip it before we open it, before we send it to OpenGL. I believe there is an actual OpenGL variable we can set that will flip that, perhaps. But a really easy way to do it is just to go here, and for your UV here, for your UV coordinates, all you got to do is flip the V coordinate in your shader, and it's very simple. What we're going to do is make a new vec2 here. And then in parentheses, it's going to be vertex uv.x, vertex uv.y, like that. So this does nothing. This is just going to take a two-dimensional vertex uv and turn it into a two-dimensional vertex uv. However, what we can do here is we can flip the y now. We can say 1.0 minus vertex uv.y, and that will take the y coordinate and invert it. If you think about it, if vertex y is 1, it becomes 0. If vertex y is 0, it becomes 1. Pretty nifty. So let's save it again, and let's try running it one last time. And you should be facing right side up. Oh, what did I do? Oh, comma 1.0. Oops. Safe. Now let's run it again. There we go. He is standing right side up, and you're seeing there's these little weird transparent artifacts. It looks like the artist of this texture pack left some like glowing texture stuff left over, some non-transparent pixels that are being displayed on our image here. Now we could go in there and fix it ourselves. We could fix the texture ourselves, or we could find a different texture or whatever, but this is fine for now. So now let's, before we end this tutorial, let's go ahead and incorporate our crazy colors with the texture. So let's uncomment this, just like that. And all we're going to do is take this right here. This is the fragment color, this crazy wavy color, and we're going to multiply it by texture color. Man, my language is messed up today. I'm getting all my words mixed up. So let's save it, probably because I didn't get a good night's sleep last night. So let's run graphics tutorials, and his color is not changing because we uncommented the time thing. So let's do that. And yes, we want to set the time every frame. And this time it's going to work. Yay, look at him. He's tripping out. Isn't that amazing, guys? Well, here's your texture tutorial. In the next few tutorials, we'll actually start making little games and things, and we're going to optimize our code and do texture caching and things like that. Because right now, all of our stuff is just right here in main game.h, and that's not where we want to put it. Thanks for watching, guys. See you next time.